Hi everyone, so today I'll be going through the recursion and financial modeling section of the 2018 Further Maths Exam 1. So question 17, the value of an annuity investment in dollars after n years, VN, can be modeled by the recurrence relation shown below. What is the value of the regular payment added to the principal of this annuity investment? So over here in the recurrence relation, we know that this value over here is the initial value of the investment. And we know this value would be the compound interest, and this value over here would be the amount added to the annuity each year, as stated in the question, after n years. So we want to find out what the value what the value of the regular payment added to the principal of the annuity investment is. So therefore it would be $500, which is the amount added to the annuity investment each year. So therefore D is the correct answer. Question 18. Between the second and third years, the increase in the value of this investment is closest to. So to do this question, we did find the value of the investment in the second and third year. So basically, I wrote the values of the first, second, and third years for the value of the investment. And we want to find the increase in the value of the investment between the second and third years. So basically, to do this question, to find the increase in the value of the investment, you just do the value of the third year minus the value of the second year. So we know the value of the third year is $47,975.90. So you do $47,975.90 minus the value of the second year, which is $47,315.03. So you put that there. And if you put that on your calculator, you'll get $660.87. So to the nearest whole number would be $661. So therefore C is the correct answer. Question 19. Daniel borrows $5,000, which he intends to repay fully in a lump sum after 1 year. The annual interest rate and compounding period for 5 different compound interests are given below. When fully repaid, the loan that will cost Daniel the least amount of money is. So to do this question, basically we have to find the effective interest rate for each loan, for each of these loans given in the question. So to do this, you can either use your calculator or use the effective interest rule. So the effective interest rule is over here, which I've written. And so R represents the annual interest rate, which would be given in the question as well. And N would be your compounding periods. So that would be how to find the effective interest rate for each of these loans if you want to use that rule. Or you could use your calculator. If you have a CAS calculator, you go to menu 852 and it'll give you something like that, effective, and you have to type in a set of numbers. So you have to enter the annual interest rate here, over here, and the compounding period over here. So for example, in loan 1, it would be 12.6, which is our annual interest rate. Compounding period is 52, so you'd write it like that with effective at the front, and you hit enter, and that'll give you your effective interest rate. So just to save time, I already wrote all the effective interest rates for these loans. So we want to find the loan that will cost Daniel the least amount of money. So basically we want to find the loan that has the lowest effective interest rate, which means that he'll pay less. Daniel pay less money on his loan. So the loan that has the lowest effective interest rate is loan 4, with an effective interest rate of 13.31. So therefore D is the correct answer, loan 4. Question 20. The graph below shows the value Vn of an asset as it depreciates over a period of 5 months. Which one of the following depreciation situations does this graph best represent? So initially the graph appears to show flat rate interest because it's decreasing by the same amount for the first 2 months. So if we draw a line like that, we can see that it's flat rate depreciation is being used because it decreases by the same, the value of the asset depreciates by the same amount for the first 2 years. However, after 2 years, we can see that there's a decrease. There's an increase in the value of the asset being depreciated. so the asset is being depreciated by a greater value. So if we count the difference between here and here, if it's the same, then that suggests flat rate depreciation is being used. So 1, 2, 3, 4, 1, 2, 3, 4. So therefore it depreciates by the same amount. And if you look between month 4 and 5, 1, 2, 3, 4, it also depreciates by the same amount between those months. So we can conclude that there's another period of flat rate depreciation from month 3 to 5, or from month 2 onwards. If we draw a line there, that shows that we have the same decrease in the value of the asset each month. So if we take a look at the options, we know straight away that it's not going to be reducing balance, because we've determined that flat rate method of depreciation is being used. So it's not unit cost depreciation. So it's flat rate depreciation it's not with a decrease. As we can see, there is an increase in the value of the asset being depreciated. So the asset is being depreciated by more each month after 2 months. So therefore it'd be a flat rate depreciation with an increase in the depreciation rate after 2 months. So therefore B is the correct answer. Question 21. Which one of the following occurrence relations could be used to model the value of a perpetuity investment, PN, after n months? So basically you should know that the value of a perpetuity always stays the same. So if we try one of the following multiple choice options, the present value should always stay the same. So like the value of the perpetuity investment should always stay the same. It should not increase, because a perpetuity investment is basically putting money in the bank or putting money into an investment, and you just take out the interest. So let's try let's try option A. So we know that the present value is 120,000. So 120,000, enter 120,000, hit enter, and then you just have to reiterate. So we know that multiply that by 1.0029 minus 365. Go to 365. And there you can see that it's decreasing in value, so therefore that's not a perpetuity investment. So that's wrong. What if we try the second one? If we try the second one, B is 180,000 is our initial. And then multiply by 0.0047 minus 846. And as we can see, the value of the investment stays the same each month. The value of the investment does not change, so therefore it is a perpetuity investment, and therefore B is the correct answer. Question 22. Adam has a home loan with a present value of $175,260.56. The interest rate for Adam's loan is 3.72% per annum, compounding monthly. His monthly repayment is $3,200. The loan is to be fully repaid after 5 years. Adam knows that the loan cannot be exactly repaid with 60 repayments of $3,200. To solve this problem, Adam will make 59 repayments of $3,200. He will then adjust the value of the final repayment so that the loan is fully repaid with the 60th repayment. The value of the 60th repayment will be closest to. So to do this question, you need to use a finance solver on your calculator. So in the initial statement says Adam has a home loan with a present value of $175,260.56. So that is our present value, and it's a home loan, so it's money he borrowed from the bank, so it's entered into your calculator as positive. The interest rate for Adam's loan is 3.72% per annum, so that's our annual interest rate. So you enter that in the interest section, and it's compounding monthly, so you enter 12 over here. His monthly repayment is $3,200, so our repayments are $3,200. You enter that as negative because that's money Adam has to pay back to the bank. So the loan is to be fully repaid after 5 years. So it suggests that the loan is going to be, the future value is going to be 0 after 5 years. But Adam knows that the loan cannot be repaid with exactly 60 repayments of 3,200. So to solve the problem, Adam makes 59 repayments of $3,200. So he makes 59 repayments of $3,200. He then adjusts the value of the final repayment so the loan will be fully repaid within 60 repayments. So we need to find the value of the loan after 59 repayments, so we can determine how much or what the value of the 60th repayment will be. So you enter 59 for n, and if you put that in your calculator, you'll get a future value of negative 3557.08. So now we need to find the value of the 60th repayment. So you enter your future value as your present value over here as 3557.08, and you enter that as positive because this is the money that Adam has borrowed from the bank. And our interest rate is still 3.72% per annum, compounding monthly. We know that our future value is going to be 0 after the 60th repayment. So we want to know what the last payment will be. So the difference between 59 and 60 repayments is 1 repayment. So we want to know what the last repayment is going to be for this, so the loan is fully repaid. So last payment is 1, and the future value is 0 because that's when the loan is fully repaid. So we got to determine the payment. Put that on your calculator, and you'll get negative 3,568 and 12 cents. So therefore, E is the correct answer. Question 23, 5 lines of an amortization table for reducing balance loan with monthly repayments are shown below. The interest rate for this loan changed immediately before repayment number 28. This change in interest rate is best described as. So to do this question, you calculate the interest rate for repayment number 27 and the interest rate for repayment number 28, because we know that the interest rate changed immediately before repayment number 28. So we want to calculate the difference, the change in the interest rate. So if you calculate to calculate the interest rate for repayment number 27, you do $961.90 divided by $229,000. Sorry, $229,023.86. So 96, and that's gonna give you the monthly interest rate. So do keep that in mind. Times by 100 to make it a percentage. And if you do that in your calculator, you should get 0.41419. And now we want to calculate the interest rate for repayment number 28, which is $1,002.26 on $227,785.76. So if you do that, so that will also give you the monthly interest rate for repayment number 8. If you do that on your calculator, you get 0.44. So to calculate the change in interest rate, you'll just do the interest rate for repayment number 28 minus the interest rate, monthly interest rate for repayment number 27. And if you do that, you'll get 0.02. But keep that in mind, that's the percentage interest per month, because in the question it says the amortization table for reducing balance loan with monthly repayments. So between each repayment, that's basically 1 month. So the interest rate is 0.02% per month. So if you want to convert that to a yearly interest rate, because all our multiple choice options are per annum, an interest rate per annum, you just multiply that by 12. So if you multiply that by 12, you will get 0.24% per annum. So basically that means we have an increase in the interest rate of 0.24% per annum. So therefore A is the correct answer. Question 24. Mariska plans to retire from work 10 years from now. Her retirement goal is to have a balance of $600,000 in an annuity investment at that time. The present value of this annuity investment is $265,298.48, on which she earns interest at the rate of 3.2% per annum compounding monthly. So from this statement, we can enter some values into our financial solver. So we know that the present value of the annuity is $265,298.48. So since it's an investment, you enter it as negative on your calculator. And the interest rate is 3.24% per annum, compounding monthly, so you put 12 in. So to make this investment grow faster, Mariska will add $1,000 payment at the end of every month. So we know that she's adding $1,000 to the investment every month. So basically put negative 1,000 because that's money she's putting into her investment. So 2 years from now, she expects that the interest rate of the investment will fall to 3.2% per annum, compounding monthly. It is expected to remain at this rate until Mariska retires. When the interest rate drops, she must increase her monthly repayment if she is to reach her retirement goal. The value of this new monthly repayment will be closest to. So basically, we're trying to find the new monthly repayment for her goal of a balance of $600,000 10 years from now. So first of all, we know 2 years from now, the interest rate is going to fall to 3.2% per annum. So we need to calculate what the value of the investment is after 2 years. So 2 times 12 would give you 24, which is representative of the annuity investment after 2 years. So you put that on your finance solver and you will get a future value of negative $307,794.49. So you put this future value into your present value on the next finance solver table over here. So you put that as positive. You put it as this value would be positive on your finance solver. And you'd convert that to negative over here in your present value. So negative 307,794.49. And we know that after the 2 years, the interest rate falls to 3.2% per annum. 3.2% per annum, compounding monthly. And it is expected to remain at this rate until Mariska retires. So we know that 2 years have already elapsed. And Mariska was planning to retire 10 years from when she started her annuity investment. So that means if 2 years has passed, she has 8 years left until she retires. So you do 8 times 12, which would give you the value of the annuity after a further 8 years. So that would be 96. And then we want to find what the payments are. And we know that the future value is her retirement goal, which is a balance of $600,000 in her annuity investment. So you enter that $600,000 as positive because that's the money she will have in 10 years from now. So we got to determine what the payments are. If you do that on your finance solver in your calculator, you get negative 1854.05. So therefore, the value of her new monthly payment is $1,854 to the nearest cent. So therefore, E is the correct answer.